But you can record it from your side also if you want.
No, like my battery is dying. My laptop battery is load shedding where I stay now.
No, but what I'm saying is that even though if I'm not recording, you can record it from your side also. So you can see
All
this is
right.
the another book. Okay. So now I can start with today's lecture. So if you remember, then we did find the Fourier transform of this signal. I gave you as a homework, and this another one as a homework, and this also as an homework. So if I'm not wrong in assuming that, have you tried it? You managed to do it or not?
I did try it.
Did you manage to solve it?
Yes, except for the last one.
Okay. Let me start with the first one so that Mr. Jitain can be able to understand it in a more better way. Jitain, do you know what is UT? Unit step function.
Yes, I learned this a very long time back, so I'm just trying to refresh my memory a bit.
Okay. So if we go further, then I think I defined it somewhere. This is unit step function. The unit step function is basically that a signal which is starts from zero. If it depends on the uh, value you are using here. So if it's written as t, then this signal will start from whatever you have in bracket. So you will put it equals to greater than equals to zero. Because t, then you will put it greater than equals to zero. So means from this point means zero. The signal will have amplitude equals to one till infinite. When I'm saying infinite, infinite is on time axis. Amplitude will remain 1, whether you are putting time t equals to 2, 3, 4, whatever, up to infinite time, the amplitude of the signal remains 1. And for all the values which are before this points are t less than 0. Or you can say elsewhere, the signal is equals to 0. So if the signal is defined as t minus a ut minus if you are doing, then it means you will write it as t minus a greater than equals to 0. So for all the time values which are greater than a, the signal will have amplitude equals to 1, and for the remaining points means all the points which are t less than a, the signal will have value equals to 0. So this is the definition of this one. In a similar way, if this is that is t minus a, it will be t plus a, then it will be t greater than equals to minus a. And for all the remaining points, the signal will have amplitude equals to 0. So in this way, you can define as much as unit step function, and the amplitude will depend on the multiplying factor. So in this question, which I gave as homework last week, it was e raised to the power minus 40 ut, and then we have e raised to the power minus 5t sine 5t into ut. So if I have to start with, let's say I have this as x1t. So if I have x1t equals to e raised to the power minus 4t ut, and I have to find the Laplace transform of this. The Laplace transform of this will be x of s will be equals to, if I use the formula will be this, and then if I bring this thing in the picture, so it means that x1 x1t is equals to and 0 else. We have ut here and we have another signal here e raised to the power 14. So the unit step means unit amplitude. So it will be equals to, I'll say like this, from 0 to infinite. Why 0 to infinite? So this signal starts from 0 and it's going up to infinite. So it will be e raised to the power minus 40 into e raised to the power minus st dt. So it will be 0 to infinite. If you don't understand something, then when I'll finish writing it, you can ask your question. Now, if you find the integration of this, it will be equals to 0 to infinite. When you put the upper limit and lower limit, it will be, when you put t equals to infinite means the upper limit, then this signal will be e raised to the power minus infinite. So e raised to the power minus infinite is 0. When you will put t equals to 0 here, it will be e raised to the power 0, which will be equals to 1. So it will be 0 upon minus 4 plus s plus 1 upon 4 plus s. Why there is a positive sign here? Because when you put the lower limit, there is another minus. There is a minus here, or you can say negative here. So minus minus is plus. So that's why we have another. We can say it's a positive. So in this way, you can find the integration of this. Now there is one thing which is missing here. I explained to them last week also that you need to find the ROC. Now, if you see at this signal can converge. When this signal can converge, when this thing will have a 0 value. If this signal will be, let's say, minus 4 plus s, I explained them in a different way last week, so I'm explaining in a different way today. So, if I write it like this, infinite. So, if this thing is positive, means 4 plus s is positive, then 4 plus s into infinite will be positive. Okay, so we can say then e raised to the power minus 4 plus s infinite is equals to e raised to the power minus infinite equals to 0. But if 4 plus s is negative, then e raised to the power minus 4 plus s into infinite is e raised to the power infinite. In that case, e raised to the power infinite is equals to what? Infinite. So means we have something infinite in our solution. If we have something infinite, that means we are not able to find the value of, we are not able to find that value because we don't know what is infinite. We are not able to find the value. So you can say the signal will not converge, or we are not able to get a proper value in that case. So that means in order for this signal to converge, we need to impose a condition on it. And what's that condition? That 4 plus s must be positive, or in other words, s plus 4 or 4 plus s, whatever it is, should be greater than equals to or sorry, not greater than equals to, should be greater than 0. So means S should be greater than minus. So this is your region of convergence. So this is the only one part I did, which is the Fourier transform of x1t equals to this signal only. So x1s is equals to 1 upon s plus 4, and s should be greater than minus 4. So now what we left with is another one, e raised to the power minus 5t into sine 5t ut. So, let me assume the second part. So x2t equals to no. So x2t is this. So x2s I'm writing now directly. We have this range, which means 0 to infinite. The only thing which we need to solve now is this sine 5t. We don't have a proper explanation of this sine 5t. So if you remember your Euler's identity, it is equals to j sine 5t plus j sine 5t minus, if we have a cos, then this thing is becomes positive and there is no j here. So we can say now that x2t is equals to u of t, which can be, if we expand, or I'm putting that directly in the formula of x2s. So then x2s is equals to 0 to infinite. These signals means this one, or to be more precise, this one, they are not providing us the boundaries, or we can say the limit of integration. Only this signal is providing us this limit. So the use of this signal is that its amplitude is 1, and uh, it's providing us the limits of integration. So when you will write it here, it will be, I'm writing this 2j outside, then it will be minus 5t plus j5t minus, and then we have this e raised to the power minus st, and then we have dt. I wrote it with the different color so that you can understand that this is due to the formula of Laplace transform, e raised to the power minus st. So now if you take everything inside and solve it, it will be 1 upon 2j 0 to infinite Any questions regarding this? Hello?
No,
So far,
nothing.
no questions.
Okay. So now if we'll take the integration of it, then it will be 1 upon 2j. We'll just integrate it normally. So it will be it's 0 to infinite. Then it will be equals to 1 upon 2j. Now there's another way of finding the region of convergence. Whatever you have here, just below these expressions, you can put them greater than equals to 0. There, this is the another way of finding the region of convergence. So when you will put the upper limit, if this thing is greater than or less than 0, so you have to find it in that way that it should converge. Means I'm putting an infinite here. If I'm putting an infinite here, then infinite means this should be equals to negative. If this will not equals to negative, then there is no convergence here. Why? Because we need to make something like e raised to the power. We need to make something e raised to the power minus infinite. So if this is positive infinite, then we need to make this number this as equals to negative. So we must write it as, we'll put it, you consider it that this is equals to negative. So when you are considering that this is equals to negative, when you are imposing, so it will be e raised to the power minus infinite, and then there will be a minus sign, it is 1, and then whole is equals to divided by, and you put the upper limit from here, then it will be plus e raised to the power minus infinite minus 1 s plus j 5 plus 5. So what you are doing now is, the only thing which you need to do is find the region of convergence. So here, for it to be, sorry, there is a minus sign here. So if for here it to be negative, sorry, positive, means the whole is negative, then this part should be greater than 0, and for it to be, the whole should be equals to minus infinite, then this part must be less than 0. So you can say minus 5 plus j5 minus s should be greater than 0, and s plus j5 plus 5 should be greater than 0. Or I can tell you a trick of doing it in another way. If you just want to make sure that you don't have to think here again twice or thrice, that what you need to do, the best way is, when you are doing this thing here, when you are doing this thing here, this thing, make sure here with s the sign is positive. So if you make sure that the sign with s is positive, you can put whatever you are coming in the denominator greater than equals to greater than 0 always. So if you will make sure in that way, so if I find the region of convergence from here, you can see it is s less than, because I'll take this s to this side, s should be less than minus 5 plus j5, and from here s should be greater than minus j5 plus 5. So this is the region of convergence. We found it from thinking that what should be positive, what should be negative. But if we do it in this way, that we make it here, it in this form already, that e raised to the power minus common s minus j5 plus 5t, and this is already having a minus outside, 5 plus j5 plus s t, 0 to infinite. Then you can see that this part will come in the denominator, here it will come in the denominator, so you can put them directly, s minus j5 plus 5 greater than 0, and s plus j5 plus 5 greater than 0. So it will be s greater than s greater than j5 minus 5. So if you see, they both are same. The only difference is there is a minus sign here. So if I take a minus common here, then I can change it like this: 5 minus j5. So, or you can change this one. So if you want to make sure that this thing works in the alignment, you can do it. Now there is one more thing. So the final answer here will be, I must remove all these, and then, because you can see it in the video. So this is your 1 upon 2j 1 upon s minus j5 plus 5, and the another one is minus 1 upon, and the region of convergence here from here is, region of convergence from here is s must be greater than j5 minus 5, and s must be greater than minus j5 minus 5. So one more thing is that I told in the previous lecture that the region of convergence is not affected by your this factor, because this is your the factor which affects the phase of the signal. It will not affect the region of convergence, means where the signal will exist in frequency domain will not be affected by this. It will just tell how much signal shifted. So you can say how much is the phase difference. So when you are doing region of convergence, you will just consider the real part. So means both of these are telling us that s is greater than minus 5. And what x1t was telling us, or you can say x1s was telling us, x1 was equals to 1 upon s plus 4 s greater than minus 4, and x2s is this complete signal, and the condition was is minus 5. So if you know the way of doing it on number line, it works in that way, that is minus 4 and the another one is minus 5. So one of them is saying minus, one of them is saying in this range, this range, this is minus 5, and the another one is saying in this range. So what's the common area? The common area is s must be greater than minus 4. So your final answer will be x of s will be 1 upon s plus 4 plus 1 upon 2j. You can solve it here. I'm doing it. So it will be s plus j 5 plus 5 minus s plus j 5 minus 5 upon, if you know this thing, you have to recollect many things of your mathematics. So if you remember this, a plus jb into a minus jb is equals to a square plus b square. Let me elaborate it further. So it's basically a square minus j square b square plus ajb minus ajb. So it will cancel. These two will cancel each other, and j square is equals to minus 1, so it will be a square plus b square. So in a similar way, we have something like that here. It is s plus 5 s plus 5 plus j5 this. Okay, so you can say that this is my a, this is my a, and this is my b, and this is my b. So we can say that these two will cancel each other, and these two will cancel each other. So you can say what left is s plus j5 s plus j5 minus j5 minus 5. So you can say these two terms and these two terms cancel, so you will left with plus 10j. So you have here into 10j, or you can say this will cancel with this. So you have 10 here, this will cancel, so it will be 5. And so you can say you have x s equals to 1 upon s plus 4 plus 5 upon s plus 5 ka square plus 5 square. And your region of convergence is s greater than -4. In this way, you will solve that question. I know that it's a lengthy question, so if if you have any question, you can ask from me. Any queries on this?
None at this stage from me.
Okay. Jitain, one more thing I need to say to all of you is that you need to keep a notebook and a pen with you. So because last time also I give some questions to everyone to solve, so that you can solve it. It should be. I can't make it 100% real time experience of it like a normal class, but I'll try to make it like that,
Okay.
so that
Okay.
you do solve some question while you are there. Okay.
Okay, good.
Now the another question is, if you see it on the screen, it's t into e raised to the power minus 2 mod t. I, I gave them a hint how to solve it. If you see this, if you know how mode works, the mode works in that way. If some whatever you have in mode, if it is, you want to make sure that it should be positive always. So now we are basically doing that. We have x of t given equals to t s. So we in this question we don't know the range, so we don't have any ut. So we need to, first of all, we are not able to, you will not be able to find the Laplace transform of something if you don't know where that signal is going to exist. So you must need to find out the limits of integration. So you need to find out, and it will be given somewhere in the question. This is not providing us the limits of integration. This is not providing us the limits of integration. So the only thing which can provide us the limits of integration is this mod 3. And how a mod 3 works is equals to minus t when t is less than 0, and it's plus t when t is greater than equals to 0. So in this way you can, now you have two things here. So if I want to be more explainable in terms of unit step, I can write it like this, that t is basically equals to minus ut for t less than 0 or less than equals to, we can bring 0 equals to on both sides, or ut when t greater than equals to 0. When I'm saying ut, now I need to bring the effect of this t also, so it will be t into s. So this is the another way of writing it. If you don't want to write it in the form of ut, you can use this thing from here. So now, if you need to find the Laplace transform of this, then x of s is basically equals to, write the formula first, this. So we have two range. You see it's from minus infinite to infinite, and in this question we have two range, t less than 0 and t greater than 0. So I'm writing it. Maybe you have some questions, you can ask. So it is minus infinite to 0. What it equals to? T into 0 to infinite No, please write it yourself and then have a look at what I have done. Everything is on your screen, you can see. So make yourself understood this part. If you don't understand, then please ask me. Everyone understand this? Everyone.
Yes, sir.
Do you understand what I have done? Yes or no? Do you understand what I have done here?
Yes, sir.
Okay. Jiten, do you understand?
Yeah, I think I do.
Okay. So basically, you can say that this t is negative here, so that's why it becomes a positive here. This t is positive here, so that's why negative here. And there's no mode with this t, so we are just writing it normally. And this e raised to the power minus st came from the formula of finding the Laplace transform of the signal. So now, if you it is minus infinite to 0, what I told you is that try to make this thing positive. S must not have a something negative multiplied to it. Dt, and this is plus 0 to infinite t dt plus. So now you have a valid way of doing the region of convergence. So let me select them as two integration. One integration is this, and second integration is this. Okay, and this is a definite integration, so we can easily do it. Or for our convenience, I'm just assuming it as a, because these two factors are, you can say, almost same. The difference is one is s minus 2, another one is s plus 2. So I'm just solving integration using it as a, and then we can put the limits. So let's say limit is 1. I'm just writing as 1 and 2. We know what is 1 and 2. For this part, it is minus infinite to 0. For this part, it is 0 to infinite. So it is t. Just to make it easier for us to solve the integration, then we can just put the value of 1 and 2, the upper limit and lower limit, and then we can put the value of a. So it will be, I hope you know the how you will do this integration, but I do it like this, i.e. there's a rule, if you know that or not: inverse, exponential, logarithmic, trigonometric, and sine. So we follow this method. So what we will do here is we will do the integration. So differentiation of this, because this is degradable, and integration of this. So if you know the method, first one as it is, integration of this. So it's 1 and 2, and then minus differentiation of this with respect to t is 1, and integration of this is e raised to the power over minus a, and then integration again. So it will be t, it will be plus 1 upon a Now you put the values of your a and 1 and 2. So the first one, a is s minus 2, and 1 and 2, 1 is 0, minus infinite, and 2 is 0. So it is equals to t So put the limits of integration. So when you put the limits of integration, when you put this, it will be, when you put 0, it will be 0, and then e raised to the power 0 is 1, so it's 0 into 1 is 0. When you will put the upper limit, sorry, lower limit, then it will be minus infinite, and this will be infinite again. So this part will become equals to 0. In this part again, when you will put 0, it will be e raised to the power minus s minus 2. So now you need to find the region of convergence for this part. So in order for this to be positive, because you have a minus sign here, so in order for this to be converged, this should be less than 0. So you will must write s minus 2 must be less than 0. Why it needs to be less than 0? Because there's a minus here, there's a minus here. This minus will make these two positive. So you need to bring another minus in order to make this thing e raised to the power minus infinite. That's why you need to make sure that this part is less than 0. And when you put the upper limit, it will be, you can say the answer is s minus 2 square. And the region of convergence is this. Now for second, a is s plus 2 and 1 is 0, 2 is infinite. So it is equals to t put the upper limits, and then you can see that for this one it's converging directly, that s plus 2 must be greater than 2. So you can say the answer is minus s plus 2 square is greater than minus 2. So the final answer for both of them is, and one says s greater than minus 2, and the another one says s less than 2. So if I plot both of them on the number line, So it's -2 here and 2 here. So one of them says this range and the another one says this range. So what's the common region of convergence? It is that is your answer for this question. Now, in order, let's take a 5 minutes or let's take a 10-minute break. So it's 10:05 in my watch. We'll come back at 10:15. All right.
Okay, no problem.
Okay.
Yeah.
Oh.
Hello. Everyone back?
Hello?
Yeah. Yes. Now there are certain properties we follow in the region of convergence for Laplace transform. So the region of convergence ROC for Laplace transform. So the first property is the ROC of XS consists of strips parallel to the j omega axis in the S plane. So what this means is that as I told you that you have, suppose ROC came something like that, sigma plus j omega. So we are going to consider only the real part of it, not the frequency part of it. You can say the phase part of it. We are going to look at the real part of it. So let's say my ROC is something minus A minus B plus C something. So if I plot it, so it will be something like this. So you called it real S, and I'm saying another thing is imaginary S here. So your minus A, suppose A is less than B less than C. So it will be minus A minus B, and then you have C which is positive. So suppose C is here somewhere. So if I will find the ROC, which three of these will give together to me, so either it will be in this range, or maybe from this range to this range, or maybe from this range to this range, or maybe it's after this, after this. It depends on the question given to us, but you can see that ROC, suppose I plot it like this. Suppose it's in this range, then your ROC will be something like this. But you will say greater than C, or maybe you will say less than B, or if it's between two numbers, then you will say, let's say, between A and C, minus A and C. You can see they are the strips which are parallel to the imaginary axis. That's what we wrote here. The ROC of axis consists of strips parallel to the j omega axis in the S plane. So you can say they are parallel. You can see they are parallel to this imaginary axis. That's why whenever you are finding the ROC, and if it's not coming parallel to the imaginary axis, that means you are doing some mistake. Second property is, the second property says is that property 2 for rational Laplace transform, the R of C does not contain any poles. What that means is that suppose your XS, first of all, I need to tell what is your pole n. There's another term which is called as zero. Do you know what is pole n zero? Any one of you?
No.
Okay. Suppose I have x of s equals to s plus 2, s plus 3, s plus 1, or let's say s minus 4. You have this. So for the values of s, we can say this numerator and denominator functions are the variables of s. So for values of s, for which this x of s will become 0, are called its zeros. So if I'll put s equals to minus 2, then this function will become 0 due to this factor. If I'll put s equals to 3, this will become 0 due to this factor. So you can say the zeros comes from, zeros are from numerator polynomial, from numerator polynomial. So you can say if you will put your, if I'll write it as ns upon ds. So for all the values for s, when I'll put ns equals to 0, and I find the factors of ns. So whatever the factors of ns are my zeros. That's for this case. My zeros are minus 2 and 3. S equals s plus 2 equals to 0. So s equals to minus 2. S equals to 3. So 3 is my 0. Now if I say poles, so poles means ds for the values of s for which ds is equals to 0. Or you can say, or x of s becomes infinite. So if s equals to minus 1, then it will be 0. So 1 upon 0 is infinite. If I put s equals to 4, this will be 0. So it's 1 upon 0, it's infinite. So for all the factors of ds are poles. In this case, s equals to minus 1 and 4 are poles. Do you understand what is pole and 0 now?
Yes, 100%.
Okay. So the property 2 says that if Laplace transform is rational Laplace transform, then the ROC does not contain any pole. What will happen if ROC contains pole? So you can say what's the effect of pole is that x of s becomes infinite. So for a function to converge, the ROC must not contain any poles. Why? Because x of s becomes infinite. So you need to remember this. So if you are putting, like suppose in this case, if you are saying, so you can say that s is greater than minus 1 can be the pole. But if a mistake you are writing s greater than equals to minus 1 is the pole, then you are wrong. Because s equals to minus 1 means that you are including your pole in the region of convergence. So you need to remember that in your region of convergence, there should not be any pole. There can be zeros, but there should not be any pole. Now, third property, which is your if x of t is of finite duration, and is absolutely integrable, then ROC is entire S plane. Now, what is the meaning of term your finite duration signal? Finite duration signal is that suppose a signal is defined as UT. So, do you think that UT is a finite signal or infinite signal? What do you think? What do you think, UT is finite signal or infinite signal? I think nobody is able is on their systems. Can you hear me?
I can, sir.
Yes. Answer. XT is equals to UT. Then tell me, UT is a finite duration signal or infinite duration signal? Oh, you're not. UT is equals to 1 for t greater than equals to 0. That means from 0 to infinite. So it's an infinite duration signal. So when we are saying finite duration means, suppose I'm saying a signal like this. Let's say defined from 1, 0 to 2, 0 to 3, 4. Let's say it has an amplitude 1. Then that this signal is your finite duration signal. It can be on positive side, negative side, on both sides, but it should be a finite duration signal. And when this is the case, we will see in the questions that the signal will the ROC will be entire S plane. When I'm saying entire S plane, means it exists for any values of S. Okay. Now property 4. Property 4 is if xt is right-sided and if real S is equals to, let's say, sigma naught is in the ROC, then all values of S for which real S greater than sigma naught will also be in the ROC. What it says is that if xt is right-sided and if real S is equals to sigma naught is in the ROC, then all values of S for which real S is greater than sigma naught will also be in the ROC. It means that suppose your ROC contains S equals to 3. So all the values of S which are greater than 3 will be in the ROC. It means that if I have an ROC which contains C 3, then 3.1, 3.2, 3.4, or you can go more smaller 3.02 something, or 4, 5, 6, they will also be in the ROC. Condition should be that xt is right-sided. Right-sided means that it exists for t greater than equals to 0. Everyone understand what is right-sided signal? That the signal must exist for the values which are greater than 0, this side, in time domain, not in frequency domain I'm talking about, because we are converting the signal into frequency domain. Now, property fifth, which is can say reverse of this. If xt is left-sided, and if the line or can say point real s equals to sigma naught is in the ROC, then all values of s for which real s less than 0 will be in the will also be in the ROC. What that means here is that if xt is a left-sided signal, means the signal exists for t less than equals to 0. Then if t equals to s equals to -3 or let's say -2 is in the ROC, then all the values of s less than -3 means -2, -5, sorry, -3.2, -3.02, they will also be in the ROC. Now, if the signal is a mix of these two, which is my property 6, did I wrote them wrongly? Property 1. Yeah. If the signal is two-sided, if xt is two-sided, so that two-sided means that it exists on positive side also and negative side also. You can say right hand side also and left hand side also. And if the line real s or the point real s equals to sigma naught is in the ROC, then the ROC will consist of a strip in the S plane that includes real S equals to sigma naught. So now the last property of this is if xt is two-sided, means it exists on t less than 0 and t greater than 0. And if it contains some point or line real S equals to sigma naught, then whatever the ROC of the signal will be, it will contain real S equals to sigma naught also. That means suppose if it will be like this, suppose this is let's say 0, S equals to 0, and it's on the both sides, xt is on time positive side also and time on time axis, negative sign also, then our ROC will be something like that, a strip which will contain this point also. If S equals to 0 is in the ROC, then there will be a strip around it. Means there will be points which are on the negative side of it also and the positive side of it also. You will understand it more clearly with the help of some examples. So let's start with an example based on this. So my question, suppose xt is equals to, we are using a mode again, and you know what a mode is. So if let xt is equals to e raised to the power minus b mod t, then you have to find the Laplace transform of this for two conditions: b is greater than 0 and b is less than 0. Don't get confused yourself with mode of t, because mode of t has also conditions of greater than 0 and less than 0. Here we have a point where b is greater than 0 and b is less than 0. So if I write in the way I told you, can I write it like this? Can I write it like this? Yes. Can you hear me? Can I write it like this? Please respond. You understand?
Yes, sir. Yes, sir.
Because mode of t can is, for t greater than 0, we can replace by a ut function to find the range. So we can say for less than 0 it is minus t here multiplied with it, and for positive side it is plus t multiplied with it, ut multiplied with it. So it's in this form. So if I find the Fourier transform of this, Laplace transform of this, so what will be the Laplace transform of this? If you remember that s minus 4 example, it is s plus b, and real s or s greater than minus b is, it's what it will be, it's ROC. And if we do in a similar way, that will be a kind of homework for you, which I did earlier also, that e raised to the power bt u of minus t, if you need to find the Laplace transform of this, then it will be minus, this is a kind of homework, you have to find out this thing. So what's the Laplace transform of this? But I'm using it directly now. So it will be real s less than b. Okay. So we have two things now. Now we have to divide these two things with respect to the values given to us of this. The first condition is that b is greater than 0. So when b is greater than 0, I'm just assuming in that, suppose that b greater than 0 can be, it can be 1, 1.2, 1.3, whatever, but it is greater than 0 means it is positive always. There are two possibilities of b when it's greater than 0. And what are those? That b can be in this range also, and b is greater than 1 also. So let's say suppose my b is, I'm just assuming it as 1 by 2 so that you can understand it more clearly. B is 1 by 2. So this part is basically your real s greater than minus 1 by 2, and this part is your real s less than 1 by 2. So we have to find the Laplace transform of both of them added together. So we will add these two, and we have to find a common region of convergence for these two, this and this. So if I have, just assuming that my b is 1 by 2, means I'm just working on this part now, this part only. I'm not working on this part. I'm just working on 0, that b is between 0 and 1. So in this point range, what will be the region of convergence? The region of convergence, if I draw it like this, so if b is between this, then there will be a minus b here, and there will be a plus b here. So this says that real s greater than minus b. So it says basically this region. All the values, if I draw it like this, let me use a sketch. Otherwise, it's not really letting me draw. So it says basically S plane, suppose I say real S. So there's a minus B and a plus B. So this one says this, and this one says this. So the common region of convergence then will be, the answer for this part will be when we have this range equals to equals to 1 upon S plus B minus, and okay. Now if I elaborate it further, if B is greater than 1 also, B greater than 1 means it has a value 2, 3, 4, whatever. Again, it will be of this form. So there is no change. Why I divided it into 2? Because there will be some question, you will find that this thing is going to affect a load. We will come to those questions also. So always divide them it in this form. That B is between 0 and 1, and then it is between, okay. Then another, so you can easily solve it now if you want to rationalize it. So it will be s square minus b square in the denominator. So it is s minus b. S will cancel with s, so it will be minus 2b over, and then you have a region of convergence which is given here. Okay. Now if you have another region of convergence which is, now in this case b is less than 0. So when b is less than 0, b is less than 0 means b is negative. Let's say I'm assuming b as a negative number, and let's say -2. So we have two of them. One of the ROC, this is s plus b, real s greater than minus b, and the another one is less than b. Now, if it's negative, you can see it will become a positive, and this will be a negative number. So this will become, so if I have to plot now, so b is negative. So if I have a, here the things will change in a very different way. And why they will change in a different way is that when you will draw it on a number line, b is, because b is negative, so you can say this minus b will be somewhere here, and because b is negative, this will be here, this will be d, because b is negative. So now the first one says that the range is above it, the another one says the range will be below it. So the range will be below it. So you will write that b is negative, or you can say b is less than 0. So you will write your region of convergence in this form. Remember, we always specify these limits with respect to the lower number here and greater number here. So because b is negative, so this is basically a greater number. So that's why you will specify it in this way. Okay, now take 5 minutes break again, and then we will solve some more questions on it. And you can ask any queries. You can go through it if you want to in the meantime. Okay, let's start with the final session of this. Uh, Suppose we have two signals which are your e raised to the power minus t, means x of t is equals to u of minus t. So how you will find the Laplace transform? So if you remember in the previous question, what we did is if it's e raised to the power, we go here. So if we have e raised to the power b t, then the Laplace transform for that is, so it's shifted was s plus b, and it is this. So what we have now is there is a, in this example we have minus bt. So it will be, you need to solve these yourself. Will be Laplace transform will be minus 1 upon s plus b. At this stage, I'm just telling you how to remember this. So I'm just writing 3, 4 of these, and maybe you will be able to understand. If you have something as minus bt, whether you have a ut or u of minus t, you will get answer in the form of s plus b always. Now, if there is a ut, then the sign here is positive for this. If you have a u of minus t, it will be minus 1 upon s plus t. Now, if you have e raised to the power b t u of t, or remember we are talking about these two signal variable. This is common. So either you have e raised to the power minus bt into ut, or you have e raised to the power minus bt into u of minus t. So the answer will change like this. So e raised to the power bt into ut, or you have e raised to the power bt into, here I'm explaining, writing again. So I must do it here also, otherwise you will get confused. So it will be, okay. So if it is this, now when you have this, the answer will be 1 upon s minus p. Okay, and it will be, for this one, the answer will be minus 1 upon s minus p. Now what left is your region of convergence. For this one, the region of convergence will be s of minus b. S of minus b for this one. And for this one, just reverse the order. So it will be plus. For this one, again, whenever ut you have, it will be greater than b. For this one, just reverse the order. I think you will be able to remember the way I'm explaining you. If you don't remember, you must consider it as a homework. So you have 4 questions to solve. E raised to the power minus bt ut, which I already solved. And then you will solve e raised to the power minus bt into u of minus t. You will find its region of convergence and you will find x of s. Again, e raised to the power bt into ut and e raised to the power bt into u of minus t. So this is a kind of the homework you have to put this. And please try to do them. So now we were not on this. We were on this question. Come back to this now. I'm erasing this part. Because in video you can see this part. So I can erase from my screen anytime. So now, which one of this is this? This is this one. So the answer is this one. So you can say it is equals to minus 1 upon s plus b, and the reason for this part is s less than minus b. Then plus for this, again it's same. The only difference here is s plus 1. This is so plus minus 1 upon s plus 2 and s less than minus 2. So now you have to draw the region of convergence line. So this is minus 2, this is minus 1. So one of them says that the region of convergence is this, s less than minus 2. Another one says the region of convergence is this, means including minus 2, this. So what will be the common region of convergence for them? The common region of convergence is s less than minus 2. So your answer is equals to minus 1 upon s plus 1 minus 1 upon s plus 2 and region of convergence is s of less minus. Any query on that? No?
No, sir.
Okay. From my perception is that either you understand everything or you don't understand anything. If you don't ask any question. I don't know on which part you are, but either you understand everything when you don't ask question or you don't understand anything.
So far, I understand, sir.
Okay, that's good. Now, just take one question and I want you to try that question. So that you can do it in do this question. So it's e raised to the power 2t u of minus t and e raised to the power 3t u of t. Try this question and then I will ask separately from one of each of you, so what's the answer and What's the reason of convergence? And please try it. Don't waste time. So I'll ask around after 6 or 7 minutes. Okay. I hope you're done doing it. Ethan,
Hello?
yeah, did you solve?
I ended up at s is less than 2 and s is less than 3.
S is, what's the final one?
S is less than 2.
S less than 2 or, yeah, S less than 2. And what your answer, Digipo?
I got that as well, sir.
Okay, but I'm solving it anyways for you guys so that you know how to do it. So you must know these four I told you with their range and everything. Because in some, if the question is coming you directly, that you just have to, the question is that you have to find the Laplace transform of this. Then you will solve it with the help of integration. But if the question is coming like this we have here, then you can use the formulas directly. So it will be e raised to the power this u of minus t. So Laplace transform of which is not 1 upon s minus 2, and there is a minus sign due to this. So if there is a u of minus t, I told you the region of convergence is s less than 2. Again 3t u of minus t, and the Laplace transform is minus 3 and s less than 3. So you need to put it on the axis to 3. So one of them says that this is the region of convergence, and the another one says that this is the region of convergence. So the common region of convergence is, as both of you find out it, s less than 2. So it's correct. Okay. Now I'm just telling you a small topic in a bit of, or not in too much detail, how you will find the inverse Laplace transform. So there is a way of doing it by integration method, but the integration method is tough. So we will do it with the help of your partial fraction and with the help of the formulas which we know. So I wrote for you that e raised to the power ut is this, and this will be the, or if the ROC is this, the ROC will be this. So when you have an inverse Laplace transform, usually the ROC is given to you and XS is given to you. So based upon your ROC, you will find your inverse Laplace transform. So now, suppose we have a question x of s. I'm just taking one question today, and then we are done for today. But I'll give you some questions. You can try. Maybe you will not be able to do it, but please try it. Yes. So this real s greater than minus 1. So do you know partial fraction? Jitin,
Yes.
and Zizipo, do you know?
Sorry, sir, I missed that question.
What was the question?
Do you know partial fraction?
Oh, partial
Oh,
fractions. Yes, yes, sir.
Okay. If you know or not don't know, now I'm telling you a direct way of doing today. You can you will be able to do it very easily from now onwards. I don't know how you learned it, but now I'm telling you in a very different way. So whenever you have this is a you have to find the partial fraction because you need to write it in something in this form because they are now multiplied together, so you need to find the partial fraction to write them in the form of addition or subtraction. So if you have, let's say, something like this, xs is equal to this. So you will do it like you have two terms in denominator. So you write a upon s plus 1 plus b upon means s b divided by s plus 2. I use the term upon, so that means a divided by s plus 1 and b divided by s plus 2. If there will be three terms here, you can write c divided by s plus 3 and so on. So now how you will find the value of a? I know most of you do it like this, that you will multiply it this side, you will multiply this side, and then you will take LCM and then you will find out. But from this you can find directly a is equals to whatever you have below a here. Remove that from this equation. So what you have here is s plus 1. So remove this from this equation. So what left is s plus 2. Now put this part equals to 0. So that means let me bring math equation. So it will be a equals to s plus 1 and whatever you have here put equals to 0. So s plus 1 equals to 0, or you can say s equals to minus 1. It means in the remaining equation which you find out after removing s plus 1, sorry, I just wrote it wrong. This is s plus 2 here. You will put s equals to minus 1. So a value of a will be 1 upon minus 1 plus 2. So it will be 1. You understand it? How I did it?
Yes. Yes, I understand.
Yes, sir. Yes, sir.
Okay. So then you will find the now value of b. So what's below b on the denominator of b? S plus 2. So from this equation remove s plus 2. So what's remaining is 1 upon s plus 1. Put this s plus 2 which is under b equals to 0. So s equals to minus 2 means in this equation, the remaining equation, you will put s equals to minus 2. So it will be 1 upon minus 2 plus 1, which is equals to minus 1. So your x of s now is 1 upon s plus 1 minus 1 upon s plus 2. And the range given is real s greater than minus 1. So now you have to think on the question in a very different way. Which poles you have here? This and this. The poles you have are minus 2 and minus 1. What is the region of convergence given to you? At real S, this is your region of convergence given to you. So this is your given region of convergence, given R or C. So you can see that for this pole, it's on this side, right hand side. For this pole also, it's on this side. So if you remember that e raised to the power minus dt ut is s plus b, s greater than minus b. So if I compare it with this thing, so you can say that this pole is on the right hand side of both of them. Sorry, the region of convergence is on right hand side of both the poles. So it's on the right hand side of this pole, it is on the right hand side of this pole. So that means if I'll take inverse Laplace transform of this, then x of t is equals to a right-handed sequence. Means we have to apply that right-handed sequence now, the property which we used earlier. So it will be e raised to the power minus t into u of t minus e raised to the power minus 2t u of t. So the effect of right hand side is that they both are t. Depending upon the question, it will change to t or minus t. Now let me take another question, which is just a change in this. Because I'm saying that my region of convergence is this. Then this question will be written in a different way. You can see then region of convergence is between these two. Now for this one, for this pole, or you can say for this one, the region of convergence is on the right hand side, and for this one, the region of convergence is on the left hand side. So if the region of convergence is on the right hand side, then when you will take the inverse Laplace transform, then xt, if it's on the right hand side, then xt will be ut. Xt will contain ut. If the region of convergence is on the left side, it will be u of minus t. So we have this. So for this one, the region of convergence is on the right hand side. So your xt then for this one will be, I'm just writing the first one first, ut, ut. From where this minus came? This minus came from, this minus is from this minus. So I didn't brought it from somewhere, from the formula or something. Now, for this one, the region of convergence is on the left hand side. So now you must remember, if e raised to the power minus dt, ut is, u of minus t is there, then Laplace transform is minus 1 upon s plus b and ROC is real s less than minus b. Okay, so region of convergence is now on the negative side, or can say left hand side of it. Then there's a minus here, but there's no minus with it. So that means you have to introduce a minus. So there will be a minus here, and e raised to the power minus t u of minus t. So depending upon the region of convergence, your question will, the answer will change. Now, on the same question, I want you to try for real s less than minus 2. You will see that both of them are on, for both of them, the region of convergence is on the left hand side. So then you will see that both of them will be u of minus t. There will be a minus or plus that you have to find out yourself. So now I'm telling you the questions which you have to try based on this. You may be able to solve them if you will like do in more focused way, then, or maybe not. So it depends how you will do it. So first is 1 upon So it's 1 upon s square plus 9. And this is s upon s square plus 9. Here the region of convergence is greater than 0, it is less than 0. This is s plus 1 upon s plus 1 whole square plus 9. And this one is s plus 2 divided by s square plus 7s plus 12. And the region of convergence is between minus 4 and minus 3. Here I just want to tell you one thing. S square plus 9 can be written as x s plus 3j into s minus 3j. And then you will apply partial fraction to the remaining thing. Okay, that is your homework. And if you are not able to download the book, let me know. I'll post it in the group also. Any queries on what we have done today?
Just one from my side, sir. These two lectures that were covered last week and this week, can we reference them in the downloadable textbook? Which chapters are there which they cover?
So you are saying from the book, from which book I have taken the lecture? You are saying that. What do you mean exactly?
So if I look at the, I just downloaded the book now, Signal and Systems by Shams. With regards to lecture 1 and 2, which chapters do they cover in this textbook?
There will be I don't know the chapter name exactly on that book, but there
Okay,
will be a chapter on Laplace transform.
Laplace transforms. Okay,
The name of the chapter will be Laplace
I
transform.
think it's chapter 3.
in chapter
And
3.
there's a chapter I'm mostly using that book I use for the questions, which I will do in the form of exercise or tutorials.
Okay,
And the book I use for lectures is the other book, the Open
okay,
Air book.
okay,
Okay, and,
okay,
and for that the chapter number is 9.
okay.
Okay,
Thank you very much.
yeah, you're welcome. And I don't understand. Are you on Blackboard on this course?
So I have added my subject manually last week, but I see it hasn't been captured on the system as yet.
That's the problem. I want to upload these things on Blackboard also the video, but there is no way I can upload. So I already created a YouTube channel, and I will put these in the form of private videos maybe there.
Okay, okay.
Okay, okay. Thank you. Have a nice
Thank you
week.
very much. You
Bye
too.
bye.
Okay, bye-bye.